Section 5.5 starts on page 270. If you go back a page, you'll learn that the title of it is Performing Function Operations. When you hear the word operations in math, what do you think of?
X equals,
What?
X equals, Y equals, like functions.
Okay, those are the functions we're going to be talking about. But what about the word operations? What do you think of when you think of operations in math?
So,
like
work on solving
FX.
something.
Yeah.
Those are the operations, folks. Add, subtract, multiply, divide. Those are the operations. When they say order of operations, the last two lines are made up of these guys, right? We also do exponenting and rooting. That's an operation as well. We've been practicing that. But when you're dealing with functions, there's an additional operation. There's 5 that we have to discuss. The first 4 are ones you're very familiar with, and they don't take very long. There's a few little quirks to it that I'm going to show you, but we're only going to spend about 20% of our time on the first 4, which is addition, subtraction, multiplication, division. And then we're going to spend 80% of the time on this new one. It's called composition. You ever heard of that? Composing functions. Have you ever heard of it? And it's not like, it's like adding functions, only the word is compose. And the thing that is absolutely amazing to me is that, and Mr. Hill agrees with me, we have never ever seen a book that has this section on function operations that completely left out the composition. That's the new one. That's the most important one, and they left it out. I don't know how that happened. Completely published, and people review it and leave that something that important out. So if you'll notice on Big Ideas Math, there is a message to you that says, in order to get credit for this assignment, you will also have to do a by hand worksheet. And that worksheet is on composition because they left it out. I put it back in. Okay. So there will be a short assignment in the book and then a composition assignment on the worksheet. And both of those have to be done to get credit, whether you do it on Big Ideas or do it all on paper. Okay? All right. So let's get our first 20% out of the way. Addition, subtraction, multiplication, division. Example 1, it says let f of x equal 3 root x and g of x equal negative 10 root x. Find f plus g of x. What's gonna spook you a little bit is the notation. So let me show you. I'll write up here the notation first, and then we'll be able to run with it from there. If you have two functions f and g, this notation f plus g in parentheses of x means this. In other words, this means add f and g together. Well then, of course, this means subtract. But it looks like this. This is the way they ask the question, and it means this. And this, I'll do it backwards just for the sake of variety. That means to multiply them. So you multiply f of x times g of x. And division, if I put g on top, oops, that's not the way they write it, but that's what it means. G divided by f of x is g of x over f of x. And one stipulation about division, as always, f of x cannot be 0. If it is 0, then that's not an x that works. It's out of the domain. Okay, so that's how they're going to write it. That notation isn't that hard to get used to. So in example 1, when it says, at the very end, it says find f plus g of x and state the domain, and then evaluate it when it's 4, when x is 4, it's not that bad. Let me write them up here. F of x equals 3 root x. What's the other one? G is what?
Negative 10 root x.
And they want us to find this. That would be to take 3 root x minus 10 root x, and that is negative 7. Oops. Root x. That's a brand new function. These guys are, if you want, they call these the parents. We're going to add those two parents together and we get this kid. Kind of a stupid analogy. But it's a new function. It's a new function born of these two by using this operation. It's a new function. And the new function's name is f plus g. The name of this function is f. The name of this function is g. The name of this function is f plus g. Okay? Tells you right here. So we've got the new function f plus g, and they want us to evaluate it when x is 4. That's not very hard. Because I did the arithmetic as I wrote that down. So the value of this function f plus g when x is 4 is 14. Yeah, it would be. Negative 14. Thanks. Good catch. Everybody clear on that? It's not very hard, right? Okay. Let's do example 2. Example 2 says we're to find f minus g, and they give us two polynomials. There is going to be something that will cause you some trouble if you don't pay attention to subtraction, and that is when you subtract two functions, you have to distribute that negative sign through the back function that you're subtracting. If you don't, you only make the first term negative, and it messes it up. So what was f in example 2?
3x cubed minus 2x squared plus 5.
And g?
X cubed subtract 3x squared plus 4x minus 2.
And they want us to do f minus g, right?
Yep.
Okay. F is positive, g is negative. That negative needs to be distributed entirely through g. So this is what you're going to do. You don't have to write this step down, but you do have to pay attention to what you're doing. When you do write it, x cubed minus 3x squared plus 4x minus 2. Now, if you leave these parentheses off, if you do that, then you can see the only thing that's going to become negative is x cubed. That's the only one that's correct. The rest of these are wrong. You understand what I'm saying? You do? That negative's got to be distributed. So this is what you're thinking in your mind, and this might be what you write first. This might be your first line, but you need to focus your first attention on distributing that negative. So you may not write this, but you look at this, you go, okay, I got to change everybody's sign here. That's negative x cubed. Got to change that one. Got to change that one and that one. Because that's what you're doing, is distributing a negative through there. You don't actually have to write this line, but you got to pay attention. If you're subtracting, everything in the back function has to change their sign. And then you combine like terms. And this is the new function whose name is f minus g. Okay, so just be careful when you're subtracting. Make sure you change the second function, the one you're subtracting, this guy right here, whatever function that is, make sure you change everybody's sign in the distribution. Okay, moving along. See, we're hustling here. Next one, we want to do f times g of x, and look at example 3. I'm going to do this one a little faster. You're starting to get used to what's going on. I do f times g, it means I'm going to multiply the two together. Look at which ones I'm multiplying. Just look at it. I'm going to go a little bit faster. F times g of x is just going to be x squared root x. Right? So the new function, whose name is f times g, is just one times the other, and that's x squared root x. And there's nothing more you can do to simplify that. That's it. Can't get anything out of here. Can't push this inside. Can't multiply them together while this is radicalized. That's done. So that is the new f times g of x. And then they want you to evaluate it at, we were supposed to evaluate the last one at -2. I assume you could plug that in. I didn't observe that. Supposed to do this at 9. And so what I get is 81 times 3. 243. Okay. So I'm going to move on. Same thing with the next one. We are to find f over g of x. That means we put f on top, and f is 6x. G is x to the 3/4. Pretend that's a parenthesis. 6x over x to the 3/4. Right? X can't be 0. But we can simplify this one. If you think about it, we can. Think about this with me before you say, what? This is going to be 6x to the 1/4. Some of you are yupping me, but some of you are looking at me funny. This is an x, and this is an x, and the exponent on this x is 1, which means if I've got an x base here and an x base here, I subtract the exponents, and 1 minus 3/4 is 1/4. And it's positive because there were virtually a bigger size x at the top. We got a whole x at the top, 3/4 down here, so when we subtract, it's left in the numerator. Everybody clear? That's the simplification of that, and that's what they expect. And then we are to evaluate it when x is 16. And that would be, if you think about this too, I'm going to do a little mental math there. It's going to be 6 times 2. If x is 16. Because it's the 4th root of 16. That's what x to the 1/4 is. 16 to the 1/4 is 2 times 2 times 2 times 2 is one of those 2's. Everybody good? Okay, we're done with the operations. We're going to do a couple of story problems having to do with this right quick, and then I'm going to jump on to compositions. I guess I will since. Okay. Example 5 says, let f be root x, and let g be the square root of 9 minus x squared. Okay. Use a graphing calculator to evaluate f plus g of x, f minus g of x, f times g of x, and f over g of x when x is 2. I'll show you something cool about your calculator. Let you do this pretty quickly. Actually, look at what they have on as the picture for you on page 272. It can show you quicker and we can get moving on. Do you remember where to find the list of y's, like y1, y2, y3, y4? It's hidden deeply in your vars key. Remember that? When we had to identify, we had to write the number y, or I had to write the symbol y1 to get a regression stored in the right place. Remember that? Yep. We go vars, y vars, function y1. Remember that? All right, that's where you're going to find these y values. So what you would do to do example 5 is you would go to your y equals screen and clear it out and turn the plots off if they're on. And then I would put f, because that's the first one offered, I would put f in y1. So it would be the square root of x, close it. And then I would put g in y2, which would be the square root of 9 minus x squared. And we're not going to graph it. We're just using this to hold our y's here. And then notice what they do in the little gray screen to the right of the solution. It's pretty tiny there. But they want you to do all 4 functions. And so all you have to do is go to your home screen, now that we've got y1 and y2 in there, and it will treat it like a function. What we want to do when we add g or f to g is we want to do f of 2 plus g of 2. In calculator notation, that's y1 of 2 plus y2 of 2. You see it? So we go to the var, and on the home screen you go vars, y vars, function, grab the y1, put a parenthesis and a 2 inside. That's like saying f of 2. Yeah. Do the same thing with y2, so you're going to add and then go to your vars key to get to your y list and go y2 of 2 and hit enter.
Did you get this?
Oh, I see.
Yeah, I got a card number. So we were just like, literally just like sliding like this across the, so bad. The worst spot is when you want to slide it, and you slide it, and then you hit it with your iPad.
Yeah, you are. That's right. And then you go.
Okay, so we all successful with the plus?
Yeah.
Yeah? Now here's what's cool, folks. I gotta get my Y2, just a minute, bars, Y bars, function, Y2 of 2, and I hit enter and I get 3.65 oh something.
That's saying all the x's in that function are U2. And then you
Hang on, we're waiting for some stuff. Okay, now, if they want you to do all 4 operations to the same 2 functions, like they're asking us to do here, you don't have to retype it every time. What you can do is go up until that's highlighted, hit enter, and edit it by going over to the plus sign and replacing it with a minus sign. Did you catch that? So for those of you watching, let me just show you right quick what I did. I'm going to clear this. After you get this done right here, you can go up and highlight that and hit enter, and then go back over here to the plus sign and just replace it with a minus to do the next operation and hit enter, and that gives you the next one. Same thing with multiplication and division. Okay, so we get negative 0.8218 for the next one, or 9. And then we go up and highlight that one again and hit enter and go over and replace it with the times. And hit enter again, record that answer, and then go up and hit enter and replace the times with a divide. And that way you don't have to go find those Y bars every single time. Okay? Deal. Okay, now I want to talk to you about rhinos and their heartbeats and how many they have in a lifetime.
Oh, great.
Yeah. Listen up. Listen. For a white rhino, heart rate R in beats per minute and lifespan S in minutes. Oh my gosh. Lifespan S in minutes.
why would you?
Just go with it, okay?
Because they don't live long, because poachers kill them.
It's gonna be a lot of minutes.
Why do you think they're
It's gonna be a lot of minutes. Shh. So the heart rate R in beats per minute and lifespan S in minutes are related to body mass M, how big you are, how much you weigh, well, how much space you take up, by the functions. Heart rate as a function of minutes is 241 m to the negative quarter. And lifespan in minutes as a function of minutes is 6 times 10 to the 6th times the mass of the object to point to, mass of the organism. Whew. We're supposed to find R times S of M and explain what it represents. Nice. Do you think you could do R times S of M? I mean, you could do it the way we just did it here, or you could just write it down and do the arithmetic. Should we just write it down this time, see? So we got another option? Okay, so it's kind of like this up here where we got an F and a G. I didn't write them up here because we were already going faster here. But there's an F and a G. In this case, it's R and S. And we want to multiply them. So, shouldn't be that big a deal. R times S of M, if I go a little quicker, is going to be 241 m to the negative quarter. They have decimals, so I'll use decimals too. Times, what's the other one? 6 times 10 to the 6 times 10 to the 6th, and then m to the 0.2.
No,
I
I
was
was
down
down
to the
the
outside of it.
Oh.
Outside of it.
Yeah.
There you go.
Like that? Yeah?
Yep.
Okay. So this is R times S. Yeah?
Yeah.
As a function of M. They're both as functions of M. So this is what we call it. This is the new function, R times S of M equals. And they want us to find that. Do you know how to enter that in your calculator?
No.
Don't forget the capital E is for the scientific notation. So you would do, it would be parenthesis 241, just like it says there, 241x. Wait a minute, we can't plug anything in yet because we don't know what M is. Hang on. I guess they just wanted us to find R times S as a new function name. We can't actually evaluate it unless we know what M is. So what we could do is, to simplify this, we could take the 241 here times this number, couldn't we? and this m to the negative quarter times this m to the 0.2 by adding the exponents. We could do that. Right? Okay, so let's take 241. Let's go ahead and use our calculator. Take 241. 241 times, and the way we would enter that is 6. Go grab that E above the comma and a 6 and hit enter. Pretty good sized number, right? I suppose you could include all those zeros. I'm not going to. I'm going to write my answer in scientific notation because I know how to do that. You should too. So this monster number, which has 1, 2, 3, 4, 5, 6 zeros and 3 other significant digits, is 1.446 times 10 to the 9th. Because that's how many places I'd have to move the decimal place to get it to here. You following me? And it will be m to the what? You can do that in your head. Negative 0.05. This is 20 cents. This is negative 25 cents. You're a nickel in the hole.
Okay.
Oh, I thought it was 2.
Everybody okay with that?
Yeah.
This would be R times S of M. Simplified. So that's the result. This name of this thing is R times S. That's our function. And it says explain what R times S of M represents. What does R mean? What is R? What did they tell us R was?
Heart rate beats per beat.
Heart rate in beats per minute. What is S?
Lifespan.
Lifespan in minutes. So if I multiply them together, what do I get?
Their total beats per, like their heartbeats in their lifetime.
Number of beats in a lifetime?
Yep.
Does that make good sense to you? If it doesn't, you can take a look at the units. This right here is in beats per minute. So look at the units. This is called unit analysis or dimensional analysis. This one's in beats per minute. What's this one measured in? What's this one measured in?
Lifespan.
Total minutes in a lifespan.
Minutes. Yeah. This is how many minutes of life they have. If you multiply beats per minute times minutes, these cancel and you end up with the units on the multiplying of the two as beats. Total beats in a lifetime, which is what you said. But this is the unit analysis that tells you that. Okay. Then, is that all they wanted us to do? They don't want us to actually find out how many minutes is in a lifespan or nothing? How rude. Okay. We're done with that problem. Seems kind of unsatisfactory. So it seems like we're done with the lecture, not even close. Okay, we are going to do this worksheet, and it is quite useful for you to have it in your hands as we go through it because I've got examples worked out for you. So when everybody has one, I'll explain why I copied it the way I did. It's kind of silly. Two papers each, considered one worksheet from 5.5.
Is this the worksheet that we have to do?
Okay. Your name should go on both of them. There's not a name slot on either one. Oh, yes, there is on the first one, but on the second one, there isn't. You want to get your name on the second one because you know how much I love staples. So get your name on the second one, even though there's no place for it. Put it at the top. I pulled these exercises out of 2 or 3 other books. So I worked out the examples for you because there's nothing for you to look at to figure out how to do this. Okay, so I'm going to get rid of this stuff up here. The notation on this is called composition. You've never seen it before. And if I had to give it a common name, rather than composition of functions, I would call this the stuffing function. Composition is the stuffing function. You stuff one function into another. What's going on, okay? And it is symbolized this way. Remember how over here I wrote what f plus g means? It means to take f of x plus g of x. Remember that? Well, when you see this, it's called a composition. When you see the parenthesis f and it's an open circle, which does not mean times, it means of. F of g is how you say it. That's how you say the function. Minus, multiply, or divide. But of. F of g of x. So of is used twice. Means this. F of g of x. In other words, we're stuffing g into f. Or, in other words, we evaluate what g is, and whatever number kicks out for g of x is the function we plug into f. Is the number we plug into f.
Wait, so g of x is now the x for f?
See if you can understand this. G's y values are f's x values. That's what that means. He got it. The rest of you didn't, but we'll work on it until you get it. So don't worry if you didn't get that first. He asked the question, so I answered it. Okay. All right. So take a look at the very first one, the very first set of exercises. I want you to do 4, and I have 3 of them worked out for you to remind you what's going on. So number 24. Well, first of all, let me put g and f up here. G is equal to 2x. And f is equal to x squared plus 4. And in number 24, which is the first one I worked out, number 24 is written like this. H of g of x. That's the notation. And it means this. H of g of x. That's what it means. When you see it written like this is what it entails. So what they want us to do is to find h of g on number 24, h of g of negative 2. So that's just h of g of x. This would be h of g of negative 2, which means this, h of g of negative 2. Plug that in for x. You following that?
Yep.
Now, because g is completely contained inside the parentheses for h, I'm going to find this first. So g of negative 2 is equal to, come up here to g, that's going to be 2 times negative 2. It's 2 times whatever I'm plugging in for x, yeah?
Mm-hmm.
And that's negative 4. So now what I'm going to do is take h of negative 4. So I go to h and plug in negative 4 for x, and I get negative 4 squared plus 4, and that's 20.
So the answer is
20.
times oh wait, it's 20. Oh yeah.
The answer is 20. Do y'all see where the 20 came from in the last line? 4 squared is 16. Negative 4 squared is 16. Positive 16. Add 4, you get 20. What?
Where'd you get g of x equals 2x? Is it on the paper? Is it on the worksheet?
Yeah, it's on the top.
Look at number 24 on the top.
Okay, I see.
Sorry. Yeah, I'm actually doing exercises on the top. The ones that are circled are the assignment, but I'm doing number 24 that isn't circled to demonstrate what's going on.
Okay.
You okay with that?
Yes.
In case that makes no sense, this is what we're talking about. You can see that. Hopefully you have your worksheet in your hands. So what we do is the innermost, because we're taught to do the innermost parentheses first. So I found g of negative 2, which was negative 4. So g of negative 2 got replaced with negative 4, and so now I find h of negative 4. Now let me talk to you again about what Trey and I just said and had a conversation about that some of you didn't get. The y value in g belonging to an x value of negative 2, the y value that belongs to g of that when g is negative 2 in g is negative 4. G of negative 2 is negative 4. So negative 4 is the y value that belongs to this function when x is negative 2. So this is a y value. And that's what I plugged in here. So what I'm saying is g y values become h's x values, plugins for h. That's what composition is. They kind of switch around. Okay, let's try another one. Let's do number 25. Very same functions, different operation. We want to do If you look at number 25, I say g of h of -2, it's in a different order. So what I'm really doing is this, g of h of -2, that's what I wish to find. Because that's what 25 says if you interpret it properly. So I want to first find h of -2. I'll plug that in here. Can you do the arithmetic in your head? H, oh, did I write F? Silly of me, that should have been an H. I have too many bad habits. Okay, this is G and H, sorry. That must have been very confusing. Sorry. That's H all along, okay? So if I find H of -2, I come up here to H, I plug in -2, I'm gonna get -2 squared, which is 4, right? -2 squared, -2 times -2, that's 4. Plus 4 is 8. So this right here turned out to be 8. So what I'm really finding is G of 8. So I go over here to G and plug in an 8 for X and I get 16. That's the final answer for that question. Did you catch that?
Yes.
Okay. So the Y value, the H of X, meaning the Y value when X was -2, turned out to be 8. So now I find G of that Y value. It becomes G's X's. Okay, one more. It's number 29. And it's kind of weird. They want us to find H of X. H of H of 2. Take a look at number 29. It says H, open circle H of 2. That's H of 2. You're going, what? It just means we're going to use H twice. It's called an iteration. Okay. So find H of 2. H of 2 is going to be 8. Did I lose anybody on that? H of 2 is 8. So this result is 8. So now I got to find H of 8. Plugging it back into the exact same thing. That'll be 64 plus 4 is 68.
Could you write it somehow with the, because it's H times H, couldn't it be H squared?
No.
No?
Not in a composition. If you're doing H times H, yes.
It's kind of weird.
H squared would be when you take this and square it and you'd end up with an X to the 4th polynomial. And it would not give you 68 when you plug 8 in. Okay. H of 2 means find the innermost value and then H that. Okay. So that's the first set, and you got to do 4 problems like that. And there's examples sitting right in front of your eyeballs up there if you want, if you forget how the details. Next one gets a little rougher. Next one gives us a new F and a new G. What?
Did Kristen come in?
I don't know. Ask them. I can't remember.
No.
Okay. So on the next set, we have a new F and G. F of X is X squared, and G of X is X minus 3. And they want us to do the same sorts of things, except for sometimes they are variables. So when you do number 31 on the exercises, when you do number 31, it's just like you did above. Well, you're using G and F. It would be F of -2, whatever that is, you would G that. But when you get down here ways to like number 39, and they've got variables at 39 and 40, they got variables instead, it's not a big deal. 41, for example, I'll do that example for you, is F of G of -A. Take a look at 41. It says FOG, fog, of -A. This is what it means. So I just wrote down what it means is all. Are you there? We got to find G of -A. G of -A means -A in for X. So I get F of -A minus 3. Did you catch that or not? G of -A says to replace any X's in G with -A. I get -A minus 3. Did you follow that or not? Now I got to find F of -A minus 3, which would be to replace the X's in F with -A minus 3. Catch that?
Yeah.
Then, if necessary, you simplify it, and it is necessary. When you square a binomial, you square the front one, which would square the negative also. Then you take this times this, which is positive 3A times 2. Then you square that on the back. And that's what it shows on 41 at the bottom of the page with the examples on it. One more, let's do it backwards. Let's do, instead of f of g of negative a, let's do g of f of negative a. See what happens. So I go to f of negative a first. I go up here first, and I have, do it right over here. F of negative a is going to be negative a squared, which is a squared. Following that? So this turned out to be just a squared. So I need to do g of a squared. So I go up here to g and replace the x's with a squared, and I get a squared minus 3. And you can't do anything with that. That's as good as it gets. You do the math as you go along. Simplify things as you run. Okay? Now you'll notice that I gave you this sheet all by itself. That's because I ran out of room at the bottom of this for you to do exercises, and I didn't want to put this on the back of this because you'd constantly be flipping it over and writing and flipping and writing. So you can set this side by side with this and do those exercises here. Okay? Then, when you're done with that, flip it over, and there's room to do the exercises on the back side. That's why I copied it out. All right, so the next exercise is the ones on the back of the first sheet, which is 46 to 50 that you only have to do 2 problems. This keeps progressing more and more into what you have to do on the last one. So here we go. F of x is 2x plus 5. And g is x squared minus 3x plus 2. And you'll notice, if you just glance through with your eyes, you'll notice on this set that they are all pluses and minuses, with a little multiplication thrown in. See, number 50 says 4 f of x plus 2 g of x. What do you suppose that means?
4 times
You distribute a 4 through f, you distribute a 2 through g, and add up what you get. That seem reasonable? Take a look at number 46 without putting it on the board. Well, I'll just go ahead and do it. 46 says 3. You're supposed to do 3f of x minus 2. So you do 3 times 2x plus 5, and then subtract 2. That's all. Which would be 6x plus 15 minus 2, which is 6x plus 13. Easy peasy. Do I need to demonstrate the other one?
I have a question. So
What?
if it says like g of x, say plus 5,
Uh-huh.
but it says f of x minus g of x plus 5, would you make the plus 5 negative?
Nope.
You
Nope.
flip it?
Nope. It's like saying x minus 3x plus 4 plus 5. That only belongs to this part. You know what I mean? Okay. Okay. Do I need to demonstrate the next one? It's right there for you. Y'all good with it? I'm going to move on. I'm kind of running out of time here. This last one is the actual true stuffing function. It's where we're going to get a new offspring function by composing it. Okay? And so we're not going to be plugging any numbers in. All of these others, we've had some numbers involved and things. Now we're just going to do truly a stuffing in. And notice, please notice on 63 to 68, are you looking at it with me? Look at it. On the exercises from 63 to 68, notice that every single problem gives you a new F and a new G. All the others gave you an F and a G and asked you to use the same F and G on several ways. When you get to 63 to 68, every problem has their own unique F and G. Okay? So if I was to do, like it says there, number 64, what I want to do is, notice the instructions too. It says to find F of G of X. It also says to find G of F of X. So you got 2 problems in one every time. So on number 64, this is F and G. So you have to get a new F and a new G each time. F is equal to 3x squared plus 2. And G is 2x. And we have to do 2 things. The first one is to find F composed with G. And it will be a new function. This is where the skill that you're going to gain here is, see if you really understand it. There's no numbers to plug in. We're not going to find what f of g is first and then let it do f of that number. We're not doing that. That was just to get your feet wet. Now we're throwing you in the deep end. You have to stuff all of g of x into f. In other words, what this means is to find f of 2x. Because that's what g of x is. You're to find f of 2x. And what that means is to go to f, and every place there's an x, write a 2x instead. Replace all your x's with what g is. You see that? And that new function would be 3 times 4x squared plus 2, which would be 12x squared plus 2. That's the new function whose name is f of g of x. You stuffed g into x by replacing all of the x's in f with what g is. Okay, stuffing it in. Okay, we also have to do g of f of x before we leave this problem. I'll do it right over here. G of f of x, that's a little different order now. G of f of x says to do this, to find g of 3x squared plus 2. And what that means to do is to stuff 3x squared plus 2 into all the x's in g, which would be 2 times 3x squared plus 2. That would be 6x squared plus 4. Follow that? Okay, that one wasn't too bad. Let's do one that's a little worse. Okay, the next problem I want to demonstrate for you is number 65, and it has a new f and g.
We just did 60.
I just did 65. I'm going to go back to do, I'm going to do 68. 64, you can follow on your own. 68 is, f is x plus 5 over 2. And g is x squared. That's not too bad. This won't be too bad, I don't think. You might have some trouble with it. We'll see. We have to find both compositions. I'm going to do f of g of x first. That's the same thing as f of x squared. And that is x squared plus 5 over 2. Did I go too fast? You can't simplify that. That's as good as it gets. Did I go too fast, anybody? Carter? You okay? Anybody else want me to go slower? You see what happened? Let's do g of f of x. Without writing this intermediate, what that means is I'm going to take what f is equal to and stuff it in for the x's in g, and that looks like this. Did you catch that? Now we do have to simplify this because we got to square the binomial and we got to square the 2. The binomial squared will be x squared plus 10x plus 25. Yep. The 2 squared will be 4. You may leave it like that, but big ideas may, well, they won't have composition. So you may leave it like that, which is perfectly fine. Or you can go one more step and you can divide the 4 into each of those separately and it would look like this. This or this. This is more appealing to me, but I'll give you full credit for that if you want to leave it. The reason why this is more appealing to me is because at least right here there was something we could have simplified a little bit. Think you can handle this?
Yeah.
Okay. For those of you doing the assignment on paper, there are a few problems out of the book I'd like you to do. There are 10 of them in the book, and then this worksheet. Everything that's circled on the worksheet are problems you have to do, and there's a space for you to do them on the worksheet.
Wait, then, so there's some that aren't on the
No.
You can submit it. You can submit the book part of the assignment on big ideas. But before you get full credit for the assignment, get any credit for the assignment, this has to be turned in complete as well.
Can you, the assignment on big ideas isn't published, it says we have to wait till tomorrow to do it.
Yeah.
All right, I'll change the date in just a minute, okay? I'll change the date so you can get going on it. Those of you doing it on paper, here is the book assignment. Are you ready? Is anybody doing it on paper? We got at least one, so here we go. 3 through 19 odd and 23. 3 through 19 odd and 23 and this. Okay, and the worksheet. Okay, see you bye.
Says